All right. Today we are looking at another application of trigonometry, one that you're probably a little more familiar with from geometry, and that is trigonometry with our right triangle. Now, again, this is what you're familiar with right triangles, okay? The proportions that we're going to go over today are only true when we have a right angle. We can use trigonometry for non-right triangles, but that's for another time. Okay, so again, we need a right triangle, so we need 90 degrees, which means that the other angles that we're looking at are going to be in between 0 and 90 degrees. Okay, they can't be equal to either of those. Well, we can't have a 0-degree angle. We wouldn't have a shape then. And we can't have another 90-degree angle, because then we wouldn't have a triangle anymore, right? A triangle has 180 total degrees. If this one's 90 and that one's 90, oops. If they're both 90, then there's no more for the other one, right? If we had two 90-degree angles, there's no way I can make a triangle out of that. Okay, so from here on out, our theta is going to be in between 0 degrees and 90 degrees. Now, where our theta is placed, obviously we have one of two places. In reference to our angle that we are focusing on, okay, we have the three sides of a triangle, and we have three names for them. One that is always the same is your hypotenuse, okay? You'll either see it referenced to as HYP or just H, all right? If you see an H, that means hypotenuse. The hypotenuse will always be the largest side, okay? That's kind of by definition. It is the longest side of the triangle. And okay, the hypotenuse will always be across from our right angle. Okay, in geometry, I'm not sure if you learned that angles and their opposite sides have a pretty close relationship. If you have, obviously three angles in a triangle, your smallest angle will be across from the smallest side. Oh man, I keep hitting this. Your largest angle will be across from your largest side. What did I just do? There we go. So in our right triangle, the 90 degrees is our largest angle, so the hypotenuse will be always across from that right angle. The two other sides we label depends on where our angle is. Okay, so obviously there's two other angles, but we're only focusing on one at a time. So if my angle is down here, okay, another side we have is the adjacent side. Okay, abbreviated ADJ. Now, the adjacent side is adjacent. It touches, it makes up the angle that we're looking at. Now, you're saying, well, Mr. Murray, we need two sides to make the angle. Well, the other side is always going to be the hypotenuse. So your angle touches two sides, or your angle that we're looking at is made up of two sides, one of them being the hypotenuse, and then the other one being the adjacent. Okay, so the adjacent side helps make up the angle. And then the last side we have, we call the opposite, abbreviated OPP. Okay, and the opposite side will never be touching the angle. Okay, it is on the opposite side. It is across from the angle that we're looking at. right? So most of the mistakes I see is when the angle is in a different place. So we have to be careful. All right, so here I'm going to put this up on our Google Classroom so you guys can mess around with this. Okay, if my angle is over here, right, then your opposite side would be across from it. Your adjacent side would be touching it. Okay, if we switch our angle, if I'm now looking at this angle up here, my opposite side changes. Okay, my opposite side is now the longer base here, and my adjacent side would be this vertical one. All right, so depending on where it is, what angle you're looking at, your opposite and adjacent sides will be different. The hypotenuse is always the hypotenuse. All right, so that's, like I said, that's where I see most mistakes stem from when we're talking about right triangle trigonometry. So just be careful there. All right, so the 6 trig functions we have, well, the first 3, maybe you remember from geometry. Okay, maybe not. The sine of the angle tells us the relationship or the proportion of the opposite side divided by the hypotenuse. All right, so if we're looking at it, let me see, which one do I want? Okay, here, if we want to look at it visually, okay, so this is my angle over here with the arc and the 2 dashes. So the sine compares the opposite leg here to the hypotenuse. Right? So the sine here of our angle is 32.5. Right? That gives us a specific ratio of our opposite leg to our hypotenuse. If I change the angle, it's changing the size of the opposite leg, which will change the ratio. Right? So the smaller my opposite leg is, the lower value we have for sine. When that angle increases, let me see if I can move this over. I can't move it. No. Okay. When my opposite side increases, my angle also increases, which increases the value of sine. Our cosine function, just move this over a little bit. Is the ratio of the adjacent to the hypotenuse. So again, when I am looking, now I'm looking at cosine, so I have the adjacent leg and I'm comparing that to the hypotenuse. The value of the cosine of 31 degrees is the same value as if we divided the length of the adjacent leg by the hypotenuse. Okay, so that's where that ratio comes from. That's where we get these equations from, these formulas. Right? So cosine has to do with the adjacent leg. So here, okay, we can see kind of the opposite thing happening. As my angle increases, my hypotenuse is increasing, but my adjacent leg side, that's not changing. Okay, so as I increase my angle, cosine, the value decreases, right? Here I'm starting close to 1, almost 1, and it's getting smaller because my hypotenuse is getting larger, which is increasing the denominator. Right, and then we have the tangent. And that is the ratio of the opposite over adjacent. Now I'm just going to show you the manipulative here just so you can see. All right, so here I have my opposite leg, and now I'm comparing it to my adjacent leg. So if you notice before, yesterday we talked about the range, right? For the range of sine and cosine, we can't go above 1, right? So no matter how big I make my angle, sine and cosine will never get us a number greater than 1. We're close to 1 with sine when we have a large opposite leg. I can get close to 1, but it won't ever equal 1 in a right triangle. For cosine, we get, oh, that's way too big. We get close to 1 when our angle is very small, when we're close to 0. Okay, but tangent behaves a little differently. Tangent is the comparison of the opposite leg to the adjacent leg, opposite over adjacent. So here, I can make my opposite leg much greater than my adjacent leg. And by doing that, we get a ratio that might be greater than 1. Okay, so we didn't talk about the domain and range of tangent yesterday because that's a little different. Okay, as my angle increases, my tangent increases, and it will continue to increase until you don't have a triangle anymore, until it's too big. All right, so here, we have an angle of 62. I can make that an angle of 80 almost, right? And we see that the tangent is almost 5. So the tangent can get pretty large comparatively. All right, so those are our 3 basic trig functions. You might remember them from SOHCAHTOA. All right, this little phrase gives us the relationship that we have there. Right, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So those are our 3 basic ones. But now that we're in precalculus, we're going to take it a step further. Okay, we know, or I told you, that we have the 3 others. We have cosecant, secant, and cotangent. Now remember from yesterday, cosecant is the inverse or the reciprocal of sine. So what we do is we flip our proportion. So cosecant is the relationship of the hypotenuse over the opposite. So with cosecant, we'll end up with numbers larger than 1 because usually our hypotenuse, actually not usually, always, our hypotenuse is always greater than the opposite side. Okay, secant is the reciprocal of cosine. So that is going to be the hypotenuse over adjacent. And then cotangent, we flip tangent, adjacent over the opposite. All right, so let me just make this a little neater and get rid of that there. All right, so when you are asked to find, this one of the 6 or all 6 of the trig functions, we have to make sure we label our sides depending on where our angle is, and then we just use the proportions. Any questions so far? All right. So one thing you may be asked to do All right, so you may be given a situation where you're not even told what the angle is, But you're given a triangle with some side lengths, and you have to figure everything out. So we want to find the 6 trig functions, the 6 trig ratios for the given triangle for theta. All right, so my theta is down here. So before we do anything, there's 2 things that we have to do. We have to label our sides, and we have to make sure we have all the sides. Right? I can't do the sine, which is opposite over hypotenuse, if I don't know the hypotenuse. Right? Well, what's nice about this so far is we're dealing with right triangles. With right triangles, there's a very special rule that we can use that can help us find the lengths of sides. Okay, and that would be Pythagorean theorem. Right? So just a word of warning, be careful, make sure you label your sides beforehand so you know what you're looking for. All right? Sometimes you're looking for the hypotenuse, which is what we're looking for in this case. But sometimes you're looking for one of the sides, right? So that would be your A or your B. In this case, we're looking for C. Right? So you would plug this in. 3 squared plus 4 squared equals C squared. Okay, I'm going to skip it. I'm going to let you know that C is equal to 5. If we have some time, we'll do a little extra lesson. This is called a, what is it called? Oh, it's got a special name. I forget it. It's not a special right triangle because those are the 30, 60, 90. But it is a ratio, a perfect ratio, a trigonometric ratio, maybe. I forget. I'll look it up. All right. Anytime you have a side that is 3 and 4, the hypotenuse will always be 5. All right. There's a list of other whole numbers that works for. So luckily, in this case, we're not dealing with any square roots or any weird decimals. Right. So here's my angle. Right. So we already know, we just found out that the hypotenuse was 5. With reference to this angle, okay, the 3 would be my adjacent, and the 4 would be my opposite. And that's all you need to answer this question. Right? So the sine of the angle, again, one thing I'm going to say, make sure that something follows your trig functions. Okay? You can't just say sine is equal to, 1/2. That doesn't make any sense. That would be just like saying, squared equals 4. Okay, sine is a function. You need to plug something into sine. You need to plug something into cosine, tangent. Right? So always make sure, if you're not dealing with a number, okay, that it's either followed by a theta or an x or whatever variable you're given for your angle. So this sine of theta is the opposite over hypotenuse. So the opposite is 4. The hypotenuse is 5. That's all we do. Okay, we're going to leave them as fractions. It's a little easier, right, than giving a decimal. I mean, you could give a decimal. You can figure it out. But don't worry about converting. Just give me the ratio in a fraction form. All right, then we have the cosine, which is adjacent over hypotenuse. The adjacent is 3. The hypotenuse is 5. Okay. Pretty straightforward from here on out. Tangent. Okay, just be careful because tangent and cotangent are the same or very similar, right? So make sure tangent is the opposite over adjacent. So 4 over 3. That's greater than 1, but that's okay. We said that might happen. And then your other 3, you're just flipping these answers. Okay, so cosecant, be careful. Although it's got the name, it's got co part of the name, cosecant is tied with sine. So cosecant would be 5 over 4. Secant is tied in with cosine, and that would be 5 over 3. And then cotangent, well, that goes with tangent. That would be 3/4. All right, so we found out all of our trig ratios. Any question? All right, I'm going to do one more quick example, just in case the numbers don't work out nicely. Okay, so now we have a triangle. Here's our angle at the top now. All right, so a little different. I have 4 as my hypotenuse. I have 2 as my adjacent side. So before we do anything, we have to figure out our opposite side. All right, so this is where I was saying be careful. Now I'm looking for my A or my B. It doesn't matter which one you make which. You can do 2 squared plus B squared equals 4 squared, or you could do A squared plus 2 squared equals 4. All right, you can switch those. That's okay. Your hypotenuse has to be your hypotenuse. So here I'll do it out because this is not going to be a nice one. So I get 4 plus B squared equals 16, which would give me B squared equals 12. So B would be the square root of 12. Now, here we want to reduce this. So I don't know if this isn't something, I think we talked about it briefly once. All right, I'm going to break this up. All right, 12 multiples of 12 are 4 and 3. The square root of 4 is 2. The square root of 3 is going to stay that. So my opposite side now is 2 times the square root of 3. Right? We're going to leave it like this because keeping the square root there is a lot nicer than dealing with decimals again. All right? So my sine, right, is my opposite over my hypotenuse. Here we can reduce this, right? I have 2 over 4 reduces to 1/2. So I get root 3 over 2. And hey, that kind of looks a little familiar. Right? This might be a 30, 60, 90 triangle. Right? We saw this in our unit circle. Cosine, well, that's going to be nice because adjacent is 2. Hypotenuse is 4. That just gets us 1/2. Tangent, opposite to root 3 over adjacent 2. We just have the square root of 3. Okay? And then just be careful. We deal with the same thing when we have the flipped, right? So let's just look at cosecant. Yeah, we're running out of time. So cosecant is going to be this flipped. So I have 2 over root 3. Well, here we have that issue. I don't like that root 3 in the denominator, so we're going to change that to 2 root 3 over 3. Right, so remember how we did that yesterday. I'll just finish it off. Secant would be 4 over 2, which would just be 2. And then cotangent is 1 over root 3, right? Because this would be over 1. We flip that, which would change to root 3 over 3. Okay, any questions? Okay, now I hate doing this, but because we have Monday off, I am going to give you a small assignment over the weekend. It'll be something like this. Okay, so I'm going to give you a triangle, and you have to give me the 6 trig functions. All right. It should be up later this afternoon, so you can get it done today if you'd like. But I want to do that so then we can move on next week to some higher stuff. All right, guys. So keep an eye out for the assignment. All right, like I said, it should go up a little later today. and enjoy your Monday off, and I'll see everybody on Tuesday.